Okay, so in this session, I'll be taking you through the basic model, that is a step file of Lamborghini. So I'll be meshing it, and meanwhile I'll be covering how exactly we need to tackle all the kinds of meshing activities, how we need to clear the element checks, yeah, how we need to do the modeling inside the ANSA. Okay, these all things will cover, and then we'll see how exactly we need to prepare the text in ANSA and also in Hypermesh. So while running the analysis, how we need to debug them. So what and all the cards we need to use. Yeah, how we need to set up the text and the subcases. Finally, how we need to post-process the results with respect to the model analysis. Okay, well, let's get started with this. Okay, so I'll simply load the step file. So this is the one into ANSA. Okay, so here I'm going to start from the scratch. So once we have the model, how we need to connect them, and how we need to run the uh, model analysis. Okay, first thing is you can see the model. So this is the just cat surfaces are there, right? Now what I'll do is I'll just try to fix this deviations and all, and there are some regions you could see it is not even connected. So what do we do for this? The first thing is I would like to go with the geometry heal options. Okay, this is the heal. You can even select from the general, means this is my own toolbar which adds the data for myself, so you can even do that. Please refer my previous videos to set up your own customized ribbon bars. Okay, I'll select everything and I'll try to heal it up. Okay, now what tool does is it will automatically try to correct the features. You could see wherever it is needed, and it is trying to connect it, and you could see there are some triple cons, means there are some surfaces are there already impregnated there are some surfaces which are already overlapped, right? So we need to do some geometry cleanup activities here. So let's start doing it one by one. Okay, so let me try to delete the surfaces which are extra. So here this is the full one, and this is the half. This one also I could delete because you could see there is an again inside extension. I'll try to do the same this side, and yep, so here also we have one extra surface, and yeah, here also we have few. You can activate this so that you can select with respect to angle. These are means the regions which are not connected to BIW, so instead of connecting them by using RB2 and other things, I would like to delete them because it will take some time. Later on in future sessions I'm going to show how we gonna do that, but right now for time being I'll just consider the region which and all connected. Okay, so here I would like to completely remove this region. Okay, there are some extensions here, it's taking up everything, so I should not delete this. I think here's a small section. Let me see. This, yeah. Similarly here, there are simple small extensions are there. I would rather delete them. Okay. Here again it is extended, but no issues. It is kind of connected. Okay. There's again a triple con. I have deleted this, means there are three surfaces, so removed one. This looks fine. And yeah, so these are not connected. You could see, I can delete them. So I'm just doing some geometry cleanup activities to run a simple modal analysis on this one. Okay, so these two gone. Here it is not connected. Slight extensions are there. Let us see how we can correct it by just meshing the model. Might help me. Okay, this is fine. Let me try with this tool. There's an advanced tool in geometry. This one, the edit geometry. You can even try to use it here. Drag and drop it on the neighbor one. If it is going to work, well and good. If it is not, then we need to manually correct it. It is not working here. This region. Nope. Okay, the only best way is to connect them. Well, so first thing I would like to mesh this model. So this model might be pretty big. So let us see. So instead of 2 mm, I would like to use 10 mm mesh. We'll go with the mixed mesh. And if you want, you can even change the more mesh settings here. Okay, order, features, whatever it is. But right now this is fine. The target length is 10. And I would like to select everything and just mesh it. It will take some time. Okay, the model is being meshed. This is fine. You can just click OK. Looks fine. So what I can do here is to release the mesh because this is still in touch with CAD. Okay, you can hide the points. What you can do is you can use this release mesh tool, select everything and release. Now if we activate the FE, we have the separate FE here. This is the CAD. Okay, now for my reference here to run the model analysis, I just need the FE. So I would like to simply remove the CAD out of it now. Okay, now I would like to have a split line, so you can just create it from here to here. I would like to split. Okay, so here it is not connected. You can just try. It is not working. Let me see. One best thing I could do here is from here to here, if I split it, and if I try to drag and drop it on this, it is not going to work. Okay, so best thing I can do here is just select these two. Let me do one by one. Drag and drop it. Yeah, do the same thing this side. These two are fine. Just drag and drop it here, drag and drop it here. Instead of wasting a lot of time, within few clicks we can just correct it, because if you want to redo that project and then paste, it is going to take a lot of time for us. Yeah, now here also it's quite difficult here. Nope. This is quite tricky part. So one best thing is you can just select this tool and just drag and drop it like this. This is one method, or else you can go to paste. Okay, this one and this and this, you could see. Just try like this. If you select both, it will show it is going to connect like that. You can just try. I have selected the pair option here. So pair in the sense you just need to define only two grids, so it will try to connect to them with pairs. Okay, this one and this one, so this makes a pair likewise. Got it? So here and then here, let us join here, and then these two. Let us see. Yeah, this is fine. Here it is quite clumsy in this region. I would like to use the direct edit. Just drag and drop it on them so that it can easily correct them. Okay, let's make it straight. There's one more. Just drag and drop it here. Perfect, right? Fine. So now again I'll switch here and I'll try to remove these. It's done. Perfect. Finished, right? Similarly, at this region, I need to connect it. It's two different surfaces. Just try to drag and drop it here on this. Nope. Drag a bit. Hey, this. Okay, it's not going. You just do it this side. Okay, first I would like to connect this here. This also has an issue. Okay, this point I just need to drag it here because these two should separate, right? Let me see whether it is going to work. Not. Yeah, it's working. Up. It is extending this side. Okay, I think these are different. This should be the one related to this side. Let me see. Okay. It's a problem. Nope. It's not coming. In short, okay, it came this side. Okay, let us join this again. Perfect. We are brilliant, right? Next, do the same this side. Oh, before that I should correct this. Okay, here it is quite difficult. Let us see. I will try to use some other options. Let me just go to geometry. There's an again option called paste. I would like to go with the target and source. I would like to select this as a source. Middle click this as a target. Let us see. Perfect. Similarly this side, source, target. Perfect. Right. Now edit mesh. You should join here. This is fine at the moment. Select this, drag and drop it on this. These two. Finished. Similarly here, source and target might not work because a lot of gap is there. Yes. You can align it using morph align and do it. But I would like to go ahead with this manual option. Better go with the paste. Okay. Let's quickly do this, guys. So these two, likewise. Okay. Seriously, it is going to take a lot of time, I think. Okay, a bit more points. Let us try another method here. I hate the manual work, which is going to take a lot of time. Too much gap, but I don't have any other options because I have selected the pair option. Let us see. Perfect. Now what best I could do this side is Let's connect this one first, these two. Fine. Let us see some morph options. Let me just go to general. I would like to see the morphing, DFM, or else you can directly go to here, direct morph. From here you can choose the DFM. Okay. And here I would like to use edge fit. Let us see. Source should be this. Okay. Fine. And then I think I might need to reduce these. Shouldn't be here. Then target should be this. Sorry, this top edge. Correct. And morph. No issues, not needed. Morph. Let us see directly. Apply. Yes, you could see it is aligned. Perfect, right? And now, once you align it, how are we gonna connect them? Let me see with this direct option. Oh yes. Okay, this looks fine, right? No issues at the moment. Guys, this is how you need to debug your models. I hope it is clear for you guys. So if you have any doubts, please refer my previous sessions where I have explained how exactly you need to debug your models. Okay. So again, there is an extension, but this is fine for me because this is outside. Okay. So yeah, so you could see there are some regions I haven't even corrected them because I would like to show you some of the issues. Here also you could see these are few. Okay, I'm just keeping it as it is because I want you guys to know what and all the issues we gonna face if we have this kind of uh, mesh issues. Okay, now I'm not going to clear any of the mesh issues, so I'll just keep it as it is. But here I could see this triple con. There should be multiple macros. This one and this one I'll delete because I could see there is triple con and there are multiple PIDs there. So one row I have deleted and remaining is here. Fine. So the model is looking good. Let us see further. Now the thing is the orientation of the PIDs or the elements is not similar, right? So for that we can just go to geometry and try orient option. So here you can just select gray outside. So in one click everything will be N. Okay. The yellow is inside, the gray is outside. Perfect. Now the model is in short ready, we'll see. Okay. The first thing is we haven't done any of the quality checks, the mesh quality checks, which we are missing up here. Okay. Now what I will do is I'll just add the material and the properties. I would like to see there are a lot of PIDs. I would like to convert all PIDs into a single PID because these many PIDs I would rather not consider because there are a lot of PIDs. We'll just take one and we'll try to assign the same to everything. Right click, apply, select everything. In this case I'm doing it, but don't do it for everything. Very important. Okay, select everything and just remove this one from here and delete all the PIDs. Okay, sorry, control A, only this I will remove. Select delete Okay, gone. Only one is remaining. Now we'll see the material. Okay, so for this you can double click on this. The material assigned is MID is 1. So here it will show which is applied. The 1 is applied, this is not applied. The symbol of bulb it shows this is applied, this is not. Okay, you can just delete this. Fine. Very important thing is the material is applied whether it is defined or not when you cross verify. Okay, material should be defined for the model. So to do that you can just go to the quick filter, just search for defined, activate it. Here you could see it is not defined. You need to check this option, or else while running the model you will definitely get an error, or the model will come out of with an error showing that the material is not defined. So again you need to open and redefine the material. So remember this, very important thing. Okay, so now we have defined the material, the property is also there. Now what is the next step in the analysis, the model analysis, any analysis? So first thing is we need to do the geometry cleanup activities, and then we need to mesh the model. Okay, once we mesh the model we need to apply the properties and the material. Okay, and then once you apply these two, next step is to define the boundary conditions. Correct. So now in this case I'm going to run the free analysis, means I'm not going to apply any SPCs for this model. There is no any forced load cases or the boundary conditions for this model, just a free analysis. Okay, just to see how the model is behaving. And in the automotive industries, the first 6 degrees of freedom should be 0. Okay, they should move, and then 7th onwards it should restrict. Okay, all the first 6 degrees with respect to 6 degrees of freedom it should be the same. Okay, now all the frequency value should be 0 there. Okay, because they will be moving with respect to the 6 degrees of freedom, right? It should happen. You might ask the question, right? So first 6 degrees of freedom should move along the XYZ or translation or rotations. If it is not happening, if the components is coming out, if something is happening, what might be the scenario at that time? So if that is happening, then in the automotive industry we consider that there might be some connection issues in the model, or while defining the adhesives, the spot welds, okay, or the nuts and bolts, or all the fasteners kind of thing, you might have applied it and sometimes you might have missed it. Due to that the components might fly. Okay, so let's say the first degree of freedom is the along x direction. In that the full automotive body, like you could see here, the Ferrari, if it has all the trims included, if everything should move along the x direction itself. Okay, positive x and the negative x. If that is not happening, if all the components are just sliding or coming out, if that is the scenario, then there is something wrong with your assembly. So then we need to go rectify it. We will anyway see how the component is moving, which component is moving, where you need to assign the contacts, the fastness. According to that you can correct the model, and again fire free analysis to cross verify. Okay, and after that, after 6th mode, then you will get the global modes, and then after 10th mode you'll get all the local modes. Then you'll understand how component is step, or how the subsystems are step. Okay, if the components are too much vibrating with respect to that particular frequency, then you can understand that component is less stiff, and then we need to add more strength. Okay, we need to make more stiff. Like that we wanna judge it. Okay, this is what the funda here is. And then from the 7th mode onwards you will get to know whether the assembly is perfect or not. Means if something is flying, it shows okay the components are flying, or if it is less stiff, then it will show this particular region is less stiff, it will vibrate a lot. Okay, and then also like 7th, 8th and 9th and 10th mode, it will indicate the automotive component behavior, the torsion and the bending moments. Okay, the first should be torsion, and then it should come the bending. Okay, after that the localized mode shapes will come. Okay, the first one is the global mode shapes, the torsion and the bending, and then with respect to the component level and the subsystem level and the part level, the components will start to vibrate, and then with respect to that we'll get the frequency and the behavior of the subsystems or the components. Okay, so now in short, right now we are going to do one free analysis on this complete automotive BIW. Okay, let's see how the component is going to behave, and then as per that we will judge whether the model is right or there should be some connections or there or not, and then whether it is behaving properly or not, we gonna get to know. Okay, let's see. Now I need to define the cards and all. Okay, right now boundary conditions, there is no any fixture for this model. In short, I need to define the EIGRL card. Okay, to define that you can even define it here, or else you can go to Hypermesh and there also you can define it. Okay, both are fine. So right now, as I'm going to use this ANSA here for the modeling activities. Okay, so let us quickly see how we can define the deck in ANSA. Okay, first thing, as this is a just free model analysis, I don't need to have any of the boundary conditions or the load cases, so we need to have the EIGRL card here. Okay, for that, in the dots you can just go to here in the analysis, you have the structural and EVH. If you just activate these two, let me just show you again. If you go to analysis, structural, or you can even choose any of these. Okay, right now structural is fine. So here you have all the boundary conditions to define loads, SPCs, and load, MPCs, deload, D area, everything. Okay, if you go to others also, you have set of things to define. Fine. And then you have the grids, and you have in the bottom you can define the elements. Okay, RB2, RB3's properties, materials, sets, contacts. Okay, all the things you can able to define it here. If you are not familiar with this, if you want to use the old UI, the panel, you can go to this panels here. You can activate the modules button, so you'll have the same GUI which you had used it before. Okay, so here you can select the Optistruct or Nastran. Depending upon that, you will have all the things to define here. SOL. So if you are going to run the model analysis by using the Nastran solver, you can just choose these options. If you want to run with the Optistruct solver, you can just switch to Optistruct and use these all tools to define it. Okay, let's define the EIGRL card. So for that, what I will do is I'll just search for the EIGRL card here. You can just type EIGRL. Okay, I'm going to define new EIGRL. EIGRL also you can just have the specific value if you want to check. That time you can define EIGRL card. So right now I'm just looking for the range of frequencies, and if you want to define the number of modes which you want to extract, you can go ahead with the EIGRL card. I'll just select EIGRL new. So here methods you need to define. It's a structural. By default it will be linked to the loadstep and the load cases. Okay, now here I'll just mention free model, just naming. Okay, here V1, in the sense you can define the lowest frequency which you want to have it. V1, V2, if you just keep it blank, you could see it is mentioning V1. If you keep it blank, it is the lowest one. If you take V1 and V2 blank, then it will consider all the range. Okay, so you can see all the options are there. How you want to define, you can just select it here. So if you define only V2 and if you leave V1 blank, so it will consider the ranges below V2, the maximum value. Let's say if I define 100 Hertz here, so it will try to extract the results up to 100 Hertz. Okay, with respect to algorithm at the backend, so it will try to define the frequencies, and then we will have the from like lowest to up to 100 Hertz. Fine. Now I'm only concerned about this one. So where I'm going to define the number of routes, number of modes I would like to extract. Here I would like to specify 10 modes. It's fine to even take 15 here because 10 modes I'll have only 7, 8, 9, 10, only 4 modes for the reference. So I would like to consider 15 so that we can see the global as well as the local modes, okay, and respective frequencies also. Fine. So I hope it is clear for you. I'll just define this. Now you could see we have the methods. In that method, I have defined the EIGRL card. Now we don't have any of the header, right? So we need to know about the deck. So very important. So if you're referring this video for the first time, you need to know what is the deck, what is a header, what is the bulk data, okay, and how we gonna use it. So what and all will come under bulk data. So what will come above the bulk data, okay, what and all will we need to define in the header, okay, and then yeah, so very important. So I'll explain that things in the next sessions for your information, but right now I have defined one analysis parameter. Now we need to add the header for this. Whatever we have defined it here, it all will come under the bulk data. I can show you the deck later, okay. So now to create it, what you can do is you can manually also create it, or else you can use the shortcut. You can just right click here and go to new and define the header from here, or else you can use the structural. From here we have the header, okay. So you can just define it from the file. If you have it already, you can bring it back, or else if you have right now, you can just edit that, or else you want to define new one, you can just select which type of analysis you are doing it. Right now I'm only focusing on the model analysis, so I can just select normal modes. So if you select it, the tool will automatically try to feed these options. First one is the analysis modes, right? In the displacement plot, the stretch and strain plots is automatically just trying to define the local cards so that we can extract these results as an output, okay. And then method structural it is taking, okay. Now one parameter card it is adding, param post -1, okay. Now if you want to refer more about the parameter cards, you can go to Optistruct help and just refer param cards, and then it will explain what and all that. Okay, param auto SPC, okay, param INREL 2, and then element check option yes or no. So these all are the different parameter cards are there. So you'll get to know these things in the later sessions, but right now don't worry. So anyway, in this session also I'll explain how we need to use some of the param cards, okay. So I'll simply click OK. If you do that, you could see automatically Optistruct header is created. It has created these all the options, right? So these are the cards. Now I would like to also define one subcase. So to define that, you can just call it subcase, or else it's fine. Okay, subcase. Okay, one. Now in this, I would like to have a method structural. Okay, I'll control X. I'll just add it here. Fine. These are the outputs. So you can even define it globally, or else you can even bring them at the bottom also, so that you can have it only for the subcase specific. Okay. So you have multiple subcases 1 to 10 or in that 10. So I would like to define for everything. So in that time you can just define these things globally on outside here, so that it will only help you to have it once instead of defining all these output for each and every subcases. Or if you are looking for specifically some outputs for specific subcases, then let's say for subcase 5 I would like to only have the stress, not the displacement and strain. You can call everything, but sometimes the file size also matters, right? So in that cases you can just play around like this. Clear? You can even call this analysis here inside. Okay, it should be normal modes. Fine. So the param card, you can keep it on the top, or else you can even just keep it at the bottom. There's no issues. You can even activate the bulk data and then it will be added there. So let us see now. Okay. So even you can have some of the global outputs on the top, but right now I would like to keep it as it is. Fine. I'll click OK. I could see my deck is ready. Let me see now. We can do one thing. Once we have this all ready, you can just go to File and export this as an Optistruct deck. Okay. It will ask you for the location. I'll just define a location here. Test. Okay. Enter. It should be .fm, very important. Okay. Save it. Okay, you need to uncheck this continuation lines, and then you need to activate output all. Okay, important. And then you need to comments, you need to remove all the comments, keep it none. And here activate begin bulk and end data. So it will automatically try to define the bulk, and it will try to end the data also. These two commands are important because with respect to this, solvers, Optistruct and other solvers will take the bulk data, recognize the bulk data, it will try to read it, and then once the data is complete, if the algorithm sees end data, then it will stop reading there, and then accordingly it will start solving. Very important. Okay, once you do that, the output will be completed. You can go back and check the output file. Here we have the test, open it, and you can just right click and open with notepad to see how it looks like. Okay, so this is how our deck is looking, right? You can even run this, but if you run this, you might have some issues. Like I told you, right, in the begin bulk, the param card will be added. Now, this model will have some of the element issues because I haven't even checked the element criteria. That we are going to do it later. Just for information, if you want to run this deck, we can add one card here, param element check no, so that this deck should run. So right now I'm not going to add it, and you could see the EIGRL card will be added here. So if you want to make the changes, here you can come. Instead of 15, I would like to have 20. You don't need to open ANSA again, change it their output. You can just open the stack, change it, and save it and run. Okay, I hope this is clear. And now I'm going to remove these all. Means I would like to take you through the normal Hypermesh method. So we will try to define the deck there. I'll remove this also. And now I'm going to take this model and run. Sorry, to define the boundary conditions, I'm going to take this model into the Hypermesh. Okay, so to do that, first thing is I need to output this particular model, right? So that should be with respect to the output formats. If you go here, there are different formats. Okay, you can see Nastrin, Elastina, Radios, Optistruct. So right now I am going to run the analysis by using the Optistruct solver in Hypermesh, Hyperworks, Alter Hyperworks. So I would like to take the .fem format. So when it comes to Optistruct, so it will be in the .fem format. Okay, so right now I'll just create one folder here inside, name it as BIW for model analysis. Okay, this is the folder. Now I'll just save this as FEM format. Okay, very important guys. So while taking the output, you need to remove this continuous lines and select the latest output format 22, and then here I would like to select all output, all whatever it is that it should be output. Okay, filters nothing. In the comments, keep none. Miscellaneous, just thickness activate. If it is there, it will try to take it up. Output symbolic variables, output begin bulk keyword, it should have it. Output end keyword also, it should have it. If you don't have it, then it won't run. Both are important. Okay, now output is completed. Now I need to work on the Hyperworks. I'll just quickly start Hyperworks 2022. Okay. Now I would like to take Hypermesh. In this profile is Optistruct, create a session. If you are going to open for the first time, this is how it is going to look like. Okay, so you can just go to the file and import, and here you need to select the solver deck. Fine. So from the location, see tutorials, the basics of modal analysis, I would like to select, okay, educational purpose. This is the folder. This is the FEM file. Okay, just select this and import. Okay, see, this is all standard, don't change anything. If you want, we can change it later on, but right now this is fine. This is the model, right? You can just activate the FEM format and the mesh. It was with respect to the transparent mode. Now this is how it looks like. Now, as I said, this is the tree, and then I need to define everything. So here you could see what and all you have defined. It is already there from ANSA. We have the elements, we have the materials, we have the nodes, parts, properties also. The next thing is I would like to define the EIGRL card. So how do we need to define? You can search here EIGRL, EIGRL. Okay. In the load step, it will automatically pop up. So I'm going to define the EIGRL card. Okay. Name, if you want, you can specify. Okay. Model. And now here the card is EIGRL. So here you can define frequency 1 up to what you want. V1 and V2 you can define it. Or else you can define the number of modes, how many modes you want to extract. Okay, so now I would like to take up to 10 or 15 is also fine. You can specify that, or else you can define the range from V1 to V2 also. Okay, frequency which you want, you can define it here. But right now, instead of the frequency values, I would like to go ahead with the number of modes 15. So according to that, I would like to see how the my component is behaving. Okay, this is one. So we have defined the load steps here, correct? So you can search for the output card. Okay, you can select this, and now you can define the output card. Options, you could see yes and no. Here the keywords are there, what exactly you're looking for. I would like to have the H3D. Frequency it is asking. Okay, all, and then option, nothing. Fine. So for all, I would like to extract the H3D. Okay, this is one. And then if you want, you can manually define the subcases also. Okay, so to define that, these are the things you could see. We have the analyzer, define the boundary conditions and the load steps. Okay, if you define the load step, so it will automatically add the subcases into account. Okay, so now we have defined load step input as an EIGRL now. So we need to define the subcase. In this, we need to call a load step input, that is EIGRL card. Okay, so that the method should be taken as structural normal modes, and then you can even define the outputs, localized outputs also in this. Okay, to define that, simply right click here and select the loads, a load step. Okay, so in this load step, it is going to ask you the analysis type. So now here I am going to run only the model analysis. I would like to go ahead with the normal modes. Okay, you can just select it. You could see a lot of types on the steady state and the explicit. Okay, non-linear, random. Okay, and then we have the fatigue. Okay, transient, direct, and model, non-linear, static. Okay, so right now I'm only focused on the normal modes. You can just select SPC nothing, MPC nothing. Method fluid doesn't work here. Okay, if you have the fluids and also it is advanced one, so right now it is beyond our scope. You can just leave it. Methods, I just need to define as a structural. Okay, just select the model analysis what you have defined. and then apply. So I have taken that here, and yeah, analysis is the modes. Now subcase options. So for this subcase, what and all you would like to output. So you can define it as global level also, beginning, or else you can even define it here. For this particular subcase, I would like to output what and all. I would like to go ahead with ESE as I said, okay, all, and then I would like to go for stresses if needed, and then the displacements, go up, displacement, yeah. So likewise, whatever the output you want, you can define it. Fine. So this is how we can just define everything. So we have defined the load case and the load step, and the load step input also it is defined. Okay, we have called it here in the method structures. Okay, so once you define everything, you are good to go to run this model. Okay, now remember we have defined only one card, so I'll let you know the importance of cards, why we need to use it. Okay, I'll also let you know what and all the importance of giving the global output cards also. Okay, now let's try to run this model. To do that, you just need to click on analyzer here. You just click on this icon. It will try to tell you the location where it is going to define. I'll just click on Optistruct, and then I'll just say yes, it is going to override it. Issues, let it override. So now it will give you the console, and it will start the console, and it shows. Means it tried to run the model, so it has some issues. The first issue is, you could see the CTRIA element is distorted. So we have the element issues, element check. We need to properly check the model. So as I said initially, we need to deep dive into the model, cross verify what and all the issues are there, right? So now how do we solve this? Very important, means I purposely kept that issue for you guys because people simply mesh the model without doing any checks, the mesh quality checks, okay, and the aspect ratio check. At least minimum aspect ratio check is needed, guys, or else you will end up with these issues. Okay, now let's see how do we need to solve this is the question. Now after that, again I have kept one more secret. So if you fix this one, let us see what exactly show. Right now you could see we have the element distortion issue. Keep it like this. Now what I would do is I'll just bring that model. Okay, so here you can just go file nav, discard this one. You can just go to file input and Optistruct. Just go back once. This might be the folder, right, which we have defined it. Yeah, just open this. Let us see. Means you have already defined everything on this model, right? We have defined the methods. You can see the header, we have it in the header. It has defined the analysis, method structures, displacement, stress, what and all we have called it here. And output card we have defined, output H3D all, right? That is also taken into account. This is very important. Begin bulk is started, right? Now I just need to check for the issue. How do we need to check is the question, right, guys? So you can go here. So once you run the model, what Optistruct solver will do is it will give you the out file. It's very important. You all guys need to know how we need to read the out file. Okay, you can just see here it shows the error. Okay, there is an element distortion issue with this 145015 element. Okay, similarly if you scroll down, it shows 145015 is the element. Okay, let's see now how do we need to resolve. This is the error shows. The error occurs in model PRPDRV. This is the generalized error. If you even Google it and see, it might tell you to resolve this element distortion, and you can even add some cards to avoid it. But right now we are already seen our model has a lot of issues, right? So now how do we check it? So you can do some checks. You can go to connectivity check, okay, and then here it will ask you for the options: detect unconnected assemblies or interactively inspect assembly connectivity, or else you can directly go with this one and see, just execute the model, see which and all is not connected. So it shows two regions. Can you see these two? You can just show only these are the two things which are not connected. In short, you can delete them, okay, and then again you can go ahead, do the connectivity check, click OK, execute. Now there is no issues with this model, okay. This is with respect to connectivity, okay, and then a lot of other checks also there, okay. Some geometry check is there, and then we have the mesh check, okay, and in the mesh we have a lot of checks again, okay. Sharp edges also we have it, execute. There is no sharp edges, okay. Sharp edge type also it is asking, like that you can do. Sharp edge triple cons also you can see, exclude macro parameters, and then yeah, now let us see, execute. It should be visible in this. Is there anything visible? No. Now yeah, you could see there are a lot, right? Control A, and it shows at this region we have some issue and it is intersecting, and yeah, likewise here also we have intersecting. We have the autofix for this. If you want, you can try this. You can go ahead and autofix this region. Yeah, so this is how we can just do this sharp edges test. And next thing is, let's see another check. We have the penetration check. You can even see that. Okay, we have the nodes, free nodes also you can check it. You can go to the free nodes and then execute it. There's no free nodes, okay. Like that we can do all the checks, okay. If you want, you can even try with the geometry check. There's no issues with this. So these all are the checks we need to do it, okay. Once you finish all the checks, you need to go to the all the remaining things. Like in the surface mesh, you can just go to mesh settings. Here in the criteria, you can define the criteria, failed elements, okay. Skewness you want, you can just try, and then the warpage, okay, and then the minimum and maximum length you can define it, okay. And yeah, and with respect to that you will get the list. According to that you can correct it. Now let's try to fix the regions. As I already told you, these are the regions which I needed to fix. So what best I could do here is I'll just activate the elements. So quickly I would like to delete them, because I know these are the regions which are very clumsy, which has the issues too. Yeah, I'm just trying to delete them. Okay, this is fine. You can just quickly fill it by using the fill tool, okay. It is there in general. You can just go to geometry and fill also, fine. Similarly you can do this side also, okay. Directed it, I would like to drag and drop it here, okay. The thing is, I have cleared some issues, okay, but due to some reasons it is not giving me the aspect. So what exactly it does is, if you just keep it 0.2 here, and with respect to that it will try to search only the needle elements in your model, and it will, if you select the off elements, you just show only the worst, and it will take you there and it will try to fix it off for you, okay. This is how it works. Now this is fine, no issues at the moment. Later on I can show in the next session also that function. Now assume we have fixed all the elemental issues, okay, with respect to quality, and if you want you can even reconstruct it once by using the tool called improve fix quality. Just select everything and just middle click, okay, with respect to the elements, whatever the fixed criteria you had defined it, as per that it will try to fix it, okay. Okay, so once you reconstruct it, this is how it is going to look like. If you want you can show old one, show new, okay, it shows it, and then just click OK. Fine. So once you remesh your model, the model will be ready. You can just output this again. So what I'll do is I'll just output this one after modifying all the modifications needed. I'll just click on this, save, and yeah, it remains the same as last. I'll simply override it. Okay, now we have modified, right? What we'll do is again we'll come back here. I'll just try to open a new session. I'm not going to save it. I'll just import the solver deck again. So the same one. So just open it, import. Now it is here. Everything is defined. You could see only we have one card, that is output. We have cleared the issue with that model. You can even refer the out file and you can just try to go for that particular element, but right now you just remember how we need to do it. We knew the location and we went and we corrected it, right? Okay, so now we'll directly try to run it again. So just click on run and Optistruct, and then let's see. Yeah, you could see it shows again job completed by showing the status. Again we have the fatal error, again error during the element quality check. So it is trying to run the element quality, and yeah, so again it shows this time this element is required, and due to quality check this element has the issue. Okay, again we need to correct it. So now every time we can't clear each and every element issues, right? So for that means to run some crash and durability analysis, we need to keep element check no card, okay, so that it is going to skip this quality check, and wherever it is necessary it will forcefully give you some regions. If you have the needle elements and all, it will definitely throw an error by saying this is element which is completely distorted, you need to correct it. But for this kind of error it shows like this one, element type required, okay, and then the fatal error occurred during the model due to element quality check. This time if you want to avoid this one, to bypass this element quality check, we need to add some cards. Now how do we add it? So for that I would like to quickly show you some cards for you guys so that you can refer them. Yeah, you could see these are few param cards which I have already stored it for you guys. Can you see this? So this is the card format H3D, and I would like to print all the result, and then output HM none, so nothing from the Hypermesh. Output H3D all, this card we already defined it, right? And then the param cards. So here the very important is this one, the param card element quality check no, and there is some auto SPC card, and then param G card we have, then inertia relief 2 we have it. Yeah, this is you need to know. Okay, so instead of defining manually everything param cards and all, so I can show you one quickly here. You can just go here and search for param. Okay, you could see parameter cards, we have it here, keyword param. Okay, now these are the cards. You could see a lot of cards will be available. So here you can just select whichever you are looking for and then you try to define it. Okay, you could see a lot are there. So right now I'm not going to take you through these all the parameter cards, so I'll just quickly give you whatever I'm using it. So what I'll do is I'll simply try to copy these. Okay, I'll show you where and what we need to copy. First thing is you just need to go to the location. Okay, go back where exactly we have located. This is the one. So BIW, here you need to open the FEM file, right click, edit in notepad, and now here I would like to copy these all the global output cards. So we have output h3d. So I would like to remove everything on the top. I would like to define it. Okay. And then in the subcase one, we have everything, no issues here. In the bulk data, after the bulk data, so here you need to have these all the param cards. Okay, very important. So you can have it everything, or else you can just pick it up however you want. But right now, I'll just copy everything. Try to remember these cards. So very important right now for this particular session. In interest, param element check, I'm just trying to suppress it, bypass the element check option. So the remaining and all you can research what and all are there, but right now in the interest of time I'm going to skip this one. I'm not going to explain all the cards here. Okay, well, so you can just save this one now. Okay, so now it is saved. We will reload it and we'll see how it is added. Okay, just discard this. You can just open solver deck. Okay, this is the one. You could see the timing, this is matching. Just load it up here. Once you load it, you could see we have all the cards here, output, param card, okay, and then the result print, okay, print all results. Fine, so now the thing is I just need to run this. Let us see now. Just click on this, output, override it, and then let's see. Now if everything is fine, it should run. You could see here it shows the run summary in progress. Still we have an issue. So what would be the issue now? So we have added element check no card also. It is not going to check the element issue, but still it is showing the sense. There should be something wrong with elements where it is not connected, or it has some single cons or some needle elements. With that, if it has issues, sometimes even with checks also we couldn't figure out, that time tool will try to tell where exactly the issue is, and we can go and check and fix it. Okay, for that reason we have this warning here. If you are going to face this issue, well and good, you will learn how to fix it, but if it is not, please just know how we need to fix this kind of issues. Okay, let us see where exactly this issue is located, and we'll just check the out file for the same and try to fix it up. You can quickly view the out file from here, and you could see it is again showing me the same element check issue. So you can just scroll up and see this is the element. Okay, let us see how to correct it. This is the element 202453. Just copy this one. Okay, we will quickly load that FEM file here. You can even do this checks and all everything in Hypermesh, but right now I would like to do it in ANSA because this is mainly focused on ANSA session. Okay, so now this one, just drag and drop it into ANSA here. Optistruct, open it. Fine. Now you can double click on the elements here. Like you paste the element ID, just click on it, and it shows this element here. Let's see, this is the one. So how do we correct this? We can just activate the direct edit tool, drag and drop it here. But I think there is something wrong. You can just recognize parameters, so it's not connected somewhere. So what I would like to do is just connect it like this. Okay, now you can just remove this hot point from here. Now it looks fine there. We have resolved that issue. Let us see now, because in the Optistruct, if you go to header, you could see we have all the cards. After begin bulk, I have defined element check no, and all the cards we have it. Okay, output h3, everything is fine. Now just take this again as an output, just replace this now, save it here, put all, overwrite this. Here I would like to input file. I need to just reopen it, new. Okay, just quickly run it again. Yeah, you could see output is completed. So now we can go and cross verify. You can even view the out file here, or else you can just go to the location. You can even switch to results here. Okay, it will take you to the Hyperview directly. You could see, and the model is loaded, or else you can directly open Hyperview separately and load it up. Okay, so now H3D is loaded. You could see, if I see the results, the modes. Okay, first thing, you can just activate the eigen modes. The first mode, you could see its frequency is 0, and this is how it is trying to move. If you want to see the movement, you can just try to bring it back here. You can set the deformation here. Okay, let me make it 20. I would like to just define the scale to 20 so that you could see the movement. Okay, the first is the translation. Okay, could see the second one. This is a rotation along y, right? This is again a rotation along x, and then we have this translation along x, right? Fifth one is the again rotation along z. Yeah, so now after, could see this in minus, right? So up to sixth mode we have everything 0 in the sense the model is fine. Now the seventh mode comes here. It shows 1.43 Hertz. Now this is a complete torsion, right? See, this is fine, but you could see it is coming out in the sense this particular element is not connected to the neighboring subsystem. And here you can activate the model animation so you can see how exactly it is behaving, right? Could see it is coming out, right? Why? Because if you want to just closely observe it, if you see here, this element, this particular row does not even touching this. So while with respect to practical behavior, it is trying to hit this. Due to that, it is showing like this, it is coming out. So you can even stiffen it, you can connect it so that you can avoid that particular behavior. Okay, the first one is, you could see it is, what exactly we have, it is the torsion. Okay, torsion mode, it is a global torsion mode. Okay, and now we'll see the next one. The eighth one is the bending mode, right? It's a global bending is happening. And then ninth one again, a torsion. It is again the back mode, means towards rear end, right? It's pumping. Correct? And now 10th one also you could see, it's again a bending mode, right? Similarly, you're gonna have the other modes. I would like to quickly take you through this mode, 15th one. This is the localized modes now. Okay, up to 7, 8, 9 and 10, so you'll be having the global modes. So how the complete BIW is behaving, you can able to get it from that. Next, after that, if you would like to see how the component is locally behaving, then after 10th mode, whatever you're gonna have it, it is completely local. Okay, you could see here it is not connected, so it is coming out. So how you're gonna stiffen it is the question. Okay, now here also it is coming out. Okay, this is how we can just deal with the other modes. Let's say let me see the 14th mode. Still this is critical one here, and see this is also critical. So even this is coming out in the sense this complete panel is critical. Like that you can just see. Okay, here these are critical now, and here likewise we can deal with the model. Okay, I hope it is clear for you guys how we need to just run a simple free analysis. Okay, so in short, to conclude, so from this we're gonna see, means outcome is how exactly the complete structure is behaving, and with respect to that we can identify whether the component has some connection issues or whether all the modes is meeting a requirement, whether it is as per the record. Yeah, that is what we're going to check it. So if the component is behaving like completely abruptly abnormal, so we can just go and check the connections and correct it. Okay, this is why we just do the free analysis on all the automotive BIWs and complete trims also to check the connectivity issues. Okay, finally to summarize, we had gone through meshing activities in ANSA, right? So we had done element checks. So we had also seen a few of the advanced techniques while modeling, and then we tried to prepare the deck inside the ANSA, and then we also did deck preparation in Hypermesh as well. So and we defined a few cards and global outputs and the subcases, right? And then we try to debug the model with respect to the modeling issues, and we also seen how we need to read the output files, and then accordingly we had tried to debug the model, and also we had post processed the results and seen the results on model analysis of the BIW model. Yeah, I think that's all about the session. So in the upcoming sessions I'll be focusing on subsystems and component level model analysis. Yeah, that's all guys. See you in the next session. Thank you. Bye everyone.